Hey guys, this is 7.4. What we are doing today is adding, subtracting, and multiplying radical expressions, okay? This is, you have one more lecture before your final exam, so just make sure you know when and where you may take your final exam for this course, and congratulations on, congratulations on completing this course. I wanted to say making it this far, but it was like, that sounded bad, like you weren't going to. Of course you were. All right, so let's add, subtract, and multiply radical expressions. We can only add, subtract, and multiply radicals that are alike. That means they have the same index and the same radicand. I'm going to give you an example. For example, if you have 8 cubed root of 64, okay? 3 is your index or your root. You can use those terms interchangeably, okay? 64 is your radicand. So you need to have the 64 and the 3 up here in common in order to combine them with something else, okay? This one does not matter. This one does not have to be the same, right? This is actually what you will be adding, subtracting, or multiplying, the 8. But what you need in common is this index and this radicand. If there is no number right here, it's an understood 2. So you can combine, like if you have the square root of 2 and the square root of 2, you can say that that is 2 square root of 2, because that's an understood, it's a bunch of 2s. It's an understood 2 right here. Okay, those are common. Like radicals are radicals with the same index and the same radicand. Like radicals can also be combined with addition or subtraction by using the distributive property, which is what we'll do at the very end of class. Our last example, we'll use the distributive property. Example 6 and example 7, okay? So like terms we've used a lot, right? Like radicals are just like terms. Do you remember like terms? It was if you had x squared plus x minus 3x plus 40, yeah? What are our like terms there? It would only be this one and this one, yeah? So a positive 1, that's an understood 1, right? A positive 1x and a negative 3x can simplify to negative 2x, and then everything else would stay the same. So it would still be x squared and 40. But instead of x minus 3x, we can just call it negative 2x. So that's the same as like radicals, okay? For example, you could have 2 cubed root of 10 plus the square root of 10 plus 6 cubed root of 10. Now, are those all like? They are not, because for like, you have to have the same index and radicand. So they all have the same radicand, but you need this to be the same. This is 3, this is 2, and this is 3. So these two are the same. 2 and 6 make 8, cubed root of 10, plus the square root of 10 is how you would simplify that. Okay, so we will add or subtract as indicated. Again, these are an understood 2, so those are common. So we have an understood 1 square root of 3 plus 7 square root of 3. 1 and 7 makes 8, and then you leave the index and the radicand the same. Good. Here we have the same radicand 2 and the same index 2. 10, don't forget the minus, it goes with the 4. 10 minus 4 is 6. Everything else stays the same. Good. Here we have the same radicand, it's an understood, or sorry, the same index, it's an understood 2, right? But this is a 5 and this is a 3, so we cannot simplify it. I did not mean to switch the order. It doesn't matter, but basically you cannot simplify it. You leave it the same. Okay, here we have the same. So here we have the same root, different radicand, so we could not simplify it. Here we have the same radicand, but different roots. That's a 3 and that's a 2. So again, it cannot be simplified. It cannot be simplified any further. All right. What about down here? The square root of 27 plus the square root of 75. Those are not the same. They have the same index, but that is not the same radicand, right? However, we can simplify it. We can simplify the square root of 27 and we can simplify the square root of 75. And then we might be able to combine them after we simplify them, okay? So remember, to simplify, we use a factor tree. 27, 2 factors of 27 are 9 and 3. 9 times 3 is 27. 9 can be factored into 3 and 3. 3 remains a 3. So that is 3 times 3 times 3. 27 is 3 times 3 times 3. I can pull out 2 3s because this is a 2, right? So that simplifies to 3, and then we leave that last one under the square root, okay? Plus, I'll do 75 in a different color. 75, oh, I can also do 3. 75 divided by 3 gives me 25. So 3 times 25 is 75. The 3 stays the same. 25 becomes 5 and 5, right? That's the prime factorization. 3 times 5 is 75. I can take out the 2 5s. And I leave the 3 under the radical. Good. So we simplified it, and now we can even combine it. 3 square root of 3 plus 5 square root of 3 will give me 8 square root of 3. Good. And you can always check this in your calculator. And if you're taking an exam and you have a bunch of multiple choice options, you can just put each one in your calculator if you want, if you do it carefully. The square root of 27 plus the square root of 75, 8 square root 3. Those are the same, okay? We're going to do the same here. Notice that we already have numbers outside the radical. All that means is that when we pull a number out, or if we pull a number out, we will multiply that number with the number that's already there, okay? So let's do 20. 20 can become 10 times 2, right? 10 can become 5 times 2, and 2 stays the same. So I can see a pair I can pull out. And I need to bring down that 3. So first of all, I'm going to bring down the 3. And then I can pull out the 2. So 3 times 2 outside, the 5 stays under. Good. Okay. Now, minus 7 times 45. We've done 45 in this class. 45 becomes 5 and 9. 5 stays the same, but 9 becomes 3 and 3. So seven times 3, and then 5 stays under the radical. Okay, so that 7 is from here. That 3 is from up here. We pulled out the 2, we pulled out the 3, and we left the 5s under the radical because they did not have a pair. They were the remainder. Okay, so 3 times 2 is 6, square root of 5, minus 7 times 3 is 21, square root of 5 is negative 15, square root of 5. We can check this. 3 square root of 20, what is that? 3 square root of 20 minus 7 square root of 45 negative 15 square root 5. Same. All right, now we have, that's a negative. Negative square root of 75 plus square root of 12 minus 3 square root of 3. We're doing the same thing, okay? So 75, I think we just did 75, right? Negative 75 becomes 25 and 3, right? 25 becomes 5 times 5. 3 remains a 3. So I can pull out the 5. And it was a negative. So I'm going to bring down that negative. 5, 3 stays under. Then we have plus 12. 12 can be 3 and 4, right? 3 is prime, so it stays 3, but 4 can be factored into 2 and 2. 3 times 2 times 2 is 12. So those are, I know those are okay. I'm going to pull out the 2 and I'm going to leave the 3 under the radical. Good. This is already prime, so I'm not even going to try. I'm not even going to try to factor it. Minus 3 square root of 3. Now we're just going to combine those terms because they all have the same index of 2 and radicand of 3. Negative 5 plus 2 minus 3. You can do that however you want. You can say negative 5 minus 3 is negative 8. Plus 2 is negative 6, or you can say negative 5 plus 2 is negative 3, negative 3 minus 3 is negative 6, right? But either way, however you do it, you get a negative 6 square root of 3. Negative square root of 75 plus square root of 12 minus 3 square root of 3. Negative 6 square root of 3. Good? Okay. Three square root of 45x cubed plus x times the square root of 5x. So nothing changes just because there are variables. We are going to treat the variables the same way we treat the numbers, okay? So we have that 3. And then we're going to take 45 and simplify 45. Can I take it out? 40, or can I take anything out of 45? 45 is 9 and 5, right? 9 is 3 and 3. So I can pull out the 3 and I leave the 5. And then I have this 3 to begin with. So now it's 3 times 3, right? That's that 3. This is this 3. Now x to the third. X to the third gives me x, x, x. Okay? I can pull out a pair of x's. But one x has to stay with the 5. It could not be pulled out. all right? Or you can take this number and divide it by this number. We know this is a 2, right? So we can say 3 divided by 2, that's this 3 divided by this 2 is 1, remainder 1. So 1x comes out, 1x stays under. Okay? And then it says plus, we have x on the outside, just like the 3 was on the outside. And then 5 I know is prime and x is prime. So I'm just going to say that I cannot simplify that any further. 3 times 3 is 9x, square root 5x plus x, square root 5x. 9x plus x is 10x, square root 5x. All right, I want to show you something. Even though that's a variable, we can still check it. There is a way to check it. We just make that variable into a number, and that can kind of tell you whether, it'll tell you if it's wrong. It won't guarantee that you have the right answer, but it will tell you whether or not you have the wrong answer. So 3 square root of 45, and then I'm just going to say x is 2 cubed plus 2 square root 5 times 2. Okay. I haven't practiced this, so I hope it comes out. And then we have 10 times 2 square root 5 times 2. You get the same number. So you can be pretty confident that you have the right answer, even though there's a variable. All right, this is the cubed root. So the difference is here, because these numbers are 2, we needed 2 factors, right? 2 5s, 2 2s, 2 3s. Now that it's 3, we're going to need 3 factors, okay? So 64 can become 4 and 16, right? 16 can become 4 and 4. And I could just bring down that 4 and take these 3 4s and say that the cube root of 64 just becomes 4. Yeah? Or if you did it a different way and made a factor tree, 64 is 8 and 8, right? 8 is 4 and 2. 4 and 2. 4 is 2 and 2. So what I have is 6 2s. So I can pull out 2 2s. 2 times 2 is 4. So either way, I can get to 4. Or you could say that that was 2 and 2, 2, 2, 2, 2. Good. But the square root of 36, the cubed root of 64 is 4. You can even just throw it in your calculator, see if you get a whole number, right? 14 would be 2 and 7, right? Those are both prime. I can't take anything out, so I have to leave that the same. Cubed root of 14. 9 is obviously already in its simplest form. 4 minus 9, those are the like terms. 4 minus 9 is -5. And that has nothing it can combine with. So the cubed root of 14 minus 5. Good. If you put that into your calculator, you will get the same value as if you put that into your calculator. All right, now we are subtracting. They are all positive real numbers. There aren't any variables. That's funny. So assume all variables represent positive real numbers, but there are no variables. Okay, so we're subtracting and we're just using what we know about fractions and what we know about radicals to solve this, all right? Okay, so what is important to know of everything we know about fractions? The important thing to know for this is that when you add or subtract fractions, because here they're asking us to subtract them, you need a common denominator, right? The denominator is the bottom of the fraction. So we call this the numerator, we call this the denominator. We need a common denominator. We need this number to be the same as this number if we're going to subtract them. Right now we have a 4 and a 3. They are not in common. But what is the smallest number 4 and 3 both go into evenly? It would be a 12. Okay, so what we need to do is change the 4 to a 12 and change the 3 to a 12 without changing the value of either fraction. The way we do that is we multiply them each by each other. Does that make sense? So if I take 4 and I multiply it by 3, I will get 12, right? And if I want this to stay the same amount, I have to multiply the top and the bottom by that same number, right? Because 3 divided by 3 is 1. So real quick, if I have 2/3, I can multiply that by 3 divided by 3, and I won't actually change. It's too close. I drew them too close. 2/3. If I multiply that by 3/3 or something else like 10/10, I'm not actually changing what it's worth. I'm just changing what it looks like. 2 times 10 is 20, right? 3 times 10 is 30. And you can do it with any number. You could do it with a, you could even do it with a radical. You could multiply them both by the square root of 5 if you want. 20/30, 2/3. They give you the same, right? Okay. So I'm multiplying this fraction by 3/3. I'm going to multiply this fraction by 4/4. Okay. So, ooh, wait, I want to do something before I even do that. Sorry. I want to simplify this 45 first. Okay. So I'm going to rewrite this. 45, I can simplify into 9 and 5. 9 becomes 3 and 3. 5 stays 5. I can take the 3's out. And I leave 5 under the radical. Okay. So let's rewrite this one more time. And instead of 45, we're just going to write 3 square root of 5. So it's still 3/3 times, but this is 3 square root 5/4 minus 4/4 times the square root of 5/3. All right, so now I'm going to multiply. 3 times 3 is 9, right? 4 times 3 is 12. 4 times the square root of 5 is 4 square root of 5. 4 times 3 is 12. Okay. So now I can just subtract. So 9 minus 4, I just might keep it up here. 9 minus 4 is 5 square root of 5/12. Good. So these are in common, which means I can subtract it. 9 minus 4 is 5. The bottom stays the same. Okay. And what I did here was I changed 45 to 3 square root of 5. I could have multiplied it through as 3. So I could have said 3 square root of 45 over 12 minus 4 square root of 5 over 12. And then I would have had to work out the 45. So I would have said 3 times 3 square root of 5 over 12 minus 4 square root of 5 over 12 equals 9 square root of 5 over 12 minus 4 square root of 5 over 12. So it did not matter whether I did it first or second. So here I did it first. Sorry, here I factored out the 3, 5 first. Here I multiplied the 3 first. And then I did it. So it doesn't matter. You get the same answer. 5 square root of 5 over 12. Okay, here is where they want us to distribute. To multiply radicals, multiply together what is under the radical and multiply together what is outside the radical separately. And we're just going to distribute the square root of 3 to the binomial. So square root of 3 times the square root of 3, those are both under the radical. So I say that's square root of 9. Square root of 3 times negative square root of 2 is negative square root of 6. And now square root of 9, I can simplify to 3. Square root of 6, I cannot simplify because 6 is just 3 and 2. There are no pairs to take out. 9 was 3 and 3, so I could take the 3 out and I had nothing under the radical. So the simplest form of that multiplication problem is 3 minus the square root of 6. Here we're going to have to FOIL. First, outside, inside, last, and then we will simplify. Square root of 3 times the square root of 3 is the square root of 9. Square root of 3 times positive 8 is 8 square root of 3. Inside is minus 8 square root of 3. And then outside is minus 64. And what this is actually a conjugate. This is the conjugate of this, and we will be doing this in the next lesson. You use it to eradicate all the radicals. So you multiply this by this, making it a perfect square. This is also a perfect square. And then because this was positive and this was negative, they were opposites, they eliminated, and you only have whole numbers, you will not have any radicals. You've eliminated the radicals. So the square root of 9 is 3. Positive 8 square root of 3 and negative 8 square root of 3 eliminate each other. 3 minus 64 is 50, 61. I almost said 59. Negative 61. So if you put that in your calculator will tell you it's negative 61. All right, our final example. This is not going to be in my math lab or on any exam. So I'm going to change it to the square root of 3 instead of the square root of x plus 1. Okay. So that quantity, both of those numbers squared, means I write it twice. So it's the square root of 3 plus 2 times itself. I write it twice. I can't say the word twice and write the number 3 at the same time. I need to speak and then write. Okay, so that becomes, so just so we're clear, square root of 3 plus 2 squared is square root of 3 plus 2 times the quantity square root of 3 plus 2. Good. So we're just going to FOIL this out. Square root of 3 times the square root of 3 is the square root of 9. Square root of 3 times 2 is 2 square root of 3. 2 times square root of 3 is 2 square root of 3. And if these are all positive, I put plus signs between them. 2 times 2 is 4. Good. The square root of 9 becomes 3. 2 square root of 3 and 2 square root of 3 are like terms. So those become 4 square root of 3 plus 4. 3 and 4 are like terms. They're 7, right? So you can say 4 square root of 3 plus 7, or 7 plus 4 square root of 3. No difference. So if you put that into your calculator, not that, if you put that in your calculator and that in your calculator, you should get the same number. Sorry, I just lost my voice. Perfect timing. All right, you have one more lecture before the end of the course. Great work. Thank you for watching, and I will see you next time.